All right, so first things first, okay, these straight lines that are going across, you're going to extend it out, okay? That's going to be your x-axis in the one direction.
Whatever color you want. I don't care.
The other direction, it's going to be the negative x-axis. I'm trying to make this like these lines like perfect, and it's just not going to happen. So we're just going to do that. Negative x. Straight up is going to be the positive y. Straight down is negative y.
Oh, like the crap. I don't know why I didn't do that
It's really irritating me that this one is crooked. So we're going to try to fix it. There we go. A little better.
Oh my gosh, this is not work.
All right, so the unit circle. The farthest out you can go is 1. Okay? So right out here, okay, it's going to be a 1. Oh, why does that change to yellow?
It just mean to keep it
Yeller.
I was trying to keep it black for this part, or the color that I was using, whatever color you started with. 1, okay, at y it's 1, at the negative x side it's negative 1, and then at negative y it's negative 1. Okay, so all the way around, okay, it's got a radius of 1, okay, if you want to think about it that way as a literal circle. Now, I'm going to start with degrees, okay? Degrees, we start at 0 degrees, and we're going to work our way around. So I'm going to change colors. I'm going to use red. Okay. So I'm going to start in here. I'm going to fill my degrees in all the way around. So starting above the line, it's 0 degrees. Your first one is 30 degrees. The next one is 45 degrees. And then the next one is 60 degrees. And then straight up and down is going to be 90 degrees. Okay, so 0, 30, 45, 60, 90. Okay. If you know that side, you know the entire rest of the thing. Okay, the increments are the same. So from 90 to the next line, that's going to be, it's going to give us 120. The next one is 15 more than that, so it's 135. Next one is 15 more than that, so it's 150. All the way over, it's 180. Okay, so from 0 all the way around, it's 180 degrees. So from this line to the next one, it's 30 degrees, so that's going to be 210. To the next one, we add 15, so it's going to be 225 degrees.
Then
Add 15. So it's going to be 240.
Oh, I was adding 15.
Then straight down on the bottom, add 30. That's going to be 270. We add 30 to get to the next one, so that's going to be 300. Add 15 to the next one, 315 degrees. We add 15 to the next one, 330 degrees. And then all the way back around to where we started is 360 degrees. Okay, so from the main lines, okay, or the way I was showing you on the board before we started, okay, from thumb to pinky is 90 degrees. From thumb to finger, okay, is 30 degrees. Between these fingers is 15 degrees, and then between your last one is 30. Okay?
Okay.
So if you ever forget, that's all you have to know is that it's 30 degrees between, I'm going to draw it on here. Don't actually draw this on your unit circle. It's 30 degrees from here to here, okay? Just all the way around, okay? And 30 from here to here. So any of the main lines, okay, that are make your axis to the next line that it touches is 30 degrees. Okay, so this is another 30 here. This is 30 here. Okay, all of those fill in to be 30. Then between, okay, the other ones, these are 15s. Okay, so those are there. So as long as you know the order that it goes, okay, on one side, you can count the rest if you forget what they are. So in reality, if you memorize one chunk of it, this chunk here, from here to here, you can figure out the entire rest of the thing just by a little bit of knowledge of how a graph works. Okay?
So this part is not hard.
That's the easy part.
Right, that's the easy part.
Just fill in the degrees.
Different color.
Alright, I'm gonna go with green. We're gonna have Christmas colors inside.
I'm gonna use purple.
Alright, now we're gonna do what we call radians. Okay? These values are pi over some number. Okay? So, we start at 0. The next one, okay, the 30-degree increments, okay, the ones that are the 30s, are pi over 6s. Okay? So, this first one, so I'm going to skip the ones that are increments of 45, okay, so that way you see how to count it. So when we get to 30 degrees, this is pi over 6. Oh, hold on, that color is really hard for y'all to see. Let me switch it. I'm trying to find a darker green. Is that better? Okay. All right, so we're at 1 pi over 6. Okay? We go 30 more degrees to the 60. We're at 2 pi over 6, but that can be reduced. So the 60s are actually going to be pi over 3s. So this is going to be pi over 3. Okay, but if you need to count, it's 1 pi over 6, 2 pi over 6, 3 pi over 6 up here at 90 degrees. Okay, 3 pi over 6 reduces down to pi over 2. So the different axes on the graph, okay, are increments of pi over 2, if you want to count them that way. But you can always use the 30s, 1 pi over 6, 2 pi over 6, 3 pi over 6, go another one, 4 pi over 6, which reduces down to, it's an increment of 60, so 2 pi over 3. Then we're going to go again, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6.
Which can't be.
You can't reduce that. Okay. And then we keep going. We have another one. So this was 5 pi over 6. This is 6 pi over 6 or just pi. So to get from here to here is pi. Okay. We don't stop there though. This is 6 pi over 6. Become another 30 degrees. It's 7 pi over 6. Okay. We come to the next 30 degree increment. 8 pi over 6 or 4 pi over 3. Okay, so 8 pi over 6. We go again. 9 pi over 6, which reduces down to 3 pi over 2. Okay, so 9 pi over 6, we go another one. 10 pi over 6, which reduces down to
5 pi over 3.
5 pi over 3. probably should be consistent and write it on the other side so it's not confusing. It doesn't matter. It's however you want it.
Write it next to the line.
As long as you know what it goes with. Yeah, anyways. All right, and then, so that was 10 pi over 6, 11 pi over 6. And then all the way back around, we get to 2 pi, okay, or 12 pi over 6. Okay, so you can count them that way if you want.
So do we have to write it in the reduced form?
Yes.
Okay.
So let me show you. If you wanted to count the increments of 60s, you could also do that. You would have, well, hold on. I don't want to write on it. 1 pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3, 5 pi over 3, 6 pi over 3, or 2 pi. Okay, so you can count any of them. The 30s are going to also hit the 60s. They just reduce. Okay? You can count in increments of 60. So it would be here, 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 and then here, 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 if you wanted to count increments of 60. But if you count in increments of 60, it's pi over 3s instead of pi over 6s. If you wanted to actually count them that way.
Then are you still missing the other one?
What do you
That
mean?
scale?
Yeah, we're going to go back to those in a second. So then you can also count by your 90-degree ones. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, so you can count all of them that same way. I just always start with the 30s so that way you see how they reduce. Because you can always count in groups of 30s if you wanted to do it that way. Now, the other ones that we have are the 45s, okay? So, they're slightly different. Let me go back and find the color I was using. Slightly different, okay? They are going to be pi over 4s, okay? So, it's going to be 1 pi over 4, okay? Then we would come up to the top. It would be 2 pi over 4, which is pi over 2. Okay, we already have that, so we don't have to write it again. Okay, we come to the next one. 3 pi over 4. Then down at pi, it's 4 pi over 4. Okay, which reduces to pi. Okay, then we keep going, keep counting. So you come down to the next 45, it's going to be 5 pi over 4. Go all the way down to the bottom. 6 pi over 4 reduces to 3 pi over 2. Then 7 pi over 4. And then going all the way back around, 8 pi over 4, which reduces to 2 pi. All right. I'm just going to label, you can do it in black or a different color if you want. I'm just labeling what the points are at the axis because we're going to ultimately be filling in, don't write this part yet, but we're ultimately going to be filling in what these values, x and y coordinates of these values are. Okay? But that may end up being tomorrow because there's not a lot of time and I don't want to, well, I may start this one and then we'll do that. But anyways. Okay, so out here, okay, it's x first, then y, so it's at 1, 0. Okay, at the top, 0, 1. Okay, and honestly, these points, these 4 points should be free points when you get to your quiz. Just saying. Some people tend to miss those. Like,
0, 1.
Yeah, they forget to put the coordinates on, but you have to put all the coordinates on. All right, this one over here is negative 1, 0. And then down at the bottom, it is 0, negative 1.
Does it matter which side of the arrow you put it
No, I'm just showing that technically you're looking at the points where they intersect, so no, it doesn't matter. All right, so I'm gonna, you don't need to draw this part on your paper, but I'm gonna show you just how we're gonna start looking at figuring out what these coordinates are. So if you forget, you can visually figure out what they are, okay? The numbers that you're gonna need to be aware of are the numbers 1/2, root 2 over 2, and root 3 over 2. Okay, sorry, those are, okay? So 1/2, root 2 over 2, and root 3 over 2. You may want to somewhere, either down on the side of this paper or somewhere else, you may want to write what these are approximately equal to. Okay. 0.86 or something like that. I want to give you the exact to 3 decimal places. Square root of 3 divided by 2 is 0.866. Okay. Square root of 2 over 2 is 0.707. Okay, and then 1/2 is obviously 0.5. Okay, and I will eventually get rid of that in a minute. But if you forget what value you're looking at, okay, you can use those if you need me to repeat what they are. Since the color's kind of weird, just let me know. Or here, actually, I can go over them. Root 3 over 2, or 2 over 2, and 1 over 2. There. If you forget what value you're looking at, all you have to do is visually imagine what's happening. So I'm going to show you what I mean by that, okay? Out here, okay, I'm going to start at the 30 degree with a pi over 6 one, okay? So what's going on is that if I drop this down, okay, you don't need to necessarily write this part on because it'll just make your whole thing confusing if you do it. I'm just doing this and then I'm going to erase it. Okay, and then here, I'm actually going to do this as one solid line so I can erase it afterwards because it's going to be really annoying. If you drop this down, you're looking at an x value that's pretty close to 1. So which number is the closest to 1 out of these?
1/2. Square root of 3 over 2.
Yeah.
Okay, square root of 3 over 2. So my x coordinate, I don't know what color I'm going to end up doing this in yet, so we'll just do these ones in blue. Okay, so my x coordinate is going to be the square root of 3 over 2. Okay, and then my y coordinate here that's coming across, where does that look like it's intersecting the y-axis out of these options?
Half.
Okay, and 1/2. And there you have it. You have figured out your first coordinate.
Ew.
Okay, but again, if you memorize this top right quadrant, okay, quadrant 1, you will be able to get all the rest of them. Okay? Now, I'm going to skip the pi over 4 one for just a minute. Okay? At pi over 3, okay, it comes across here and down here. Okay? I'm going to get rid of this stuff up top. Well, I'm going to get rid of that one at least and get it out of the way because I'm going to need to write there. All right, I'm going to change and do this one in a different color again because I want them all to be clear what they are. We're going to do purple. All right, so where does the x coordinate appear to be here? 1/2. How about your y coordinate?
Square root of 3 over 2.
Okay, square root of 3 over 2. Now, what do you notice about pi over 6 and pi over 3 with their coordinates?
They're opposite.
They're opposites. Okay, so again, if you know your 30 degree one, just flip it and you get your other one.
Do we need to write that in a different color? Or did you just
I'm going to write all of them in a different color. I'm going to do all the pi over 3 in one, and then all the pi over 6s in one. All right, and then your last one, your pi over 4. Pushing it on time here, but okay, you drop it down and bring it over. What does your x coordinate appear to be here?
Square root of 2 over 2.
Yeah.
Square root of 2 over 2. How about your y coordinate?
Also square root of 2.
Okay, also the square root of 2 over 2. And do that one in orange. So this one is the square root of 2 over 2 and the square root, oh, hold on, I need to get rid of that. Square root of 2 over 2. Okay? Now, I'm going to get rid of all this other stuff, but y'all can keep it if you want it, okay? But pi over 4s are the easiest one because it's square root of 2 over 2 and square root of 2 over 2 every single time, okay? So tomorrow we'll look more at this and what happens when we get to other quadrants, but I wanted to go ahead and get you through seeing this particular one. Yeah, so that's what I'm saying. If you memorize here, it flips. So your pi over 6 finger is now on your 5 pi over 6 finger. Those coordinates are the same. The signs just change. That's all that's happening. So.